So in section 11.2, we'll be solving quadratic equations by completing the square. So we've already done factoring. We solved quadratics by factoring using the square root property, and now we will do completing the square. Okay, so this is going to look pretty confusing until we get to an example here. So if we have a quadratic that is a trinomial ax squared plus bx plus c equals 0, and it cannot be factored, completing the square is a method that we can use to help us solve that. What we're going to be doing is we are going to be rewriting this trinomial as a binomial squared. Once we do that, we can use the square root property and take the square root of both sides. So if we have x squared plus bx, so ignoring the constant, and we'll mention in a second, we're going to get the constant to the other side of the equation. So if we have x squared plus bx, so it's a binomial, two terms, and we add b over 2 squared, so that b value is the x coefficient. If we divide it by 2 and we square it, it's going to result in a perfect square trinomial. So what that's going to mean is we can rewrite x squared plus bx plus b over 2 squared, which is just going to be a number. We can end up rewriting that as x plus b over 2 squared. Okay, so once we have that, we'll be able to take the square root of both sides, and it's relatively simple. So we're going to assume that the coefficient on the x squared term, a, is equal to 1 right now for these next steps. If it's not equal to 1, then we have to divide every term by that value a to get a coefficient of 1 on the x squared term. Okay, so here are the general steps, which once again will probably look pretty confusing until we do an example. So the first step, if we are dealing with x squared plus bx plus c equals 0, the first step is to add or subtract the constant to the other side of the equation. So once we do that, then the next step is one that is kind of the main step that we just have to know how to do. We have to add b over 2 squared to both sides of the equation. So that's that b value on the x coefficient. Once we do that, the result on the left-hand side is going to be a perfect square trinomial, and the right side will be a constant. So the original x squared plus bx plus c equals 0 is going to become a binomial squared x plus b over 2 squared equals negative c plus b over 2 squared, whatever that constant happens to be on the right-hand side. After that, we use the square root property and solve it for x. Okay, so let's clear up any confusion here and do several examples. So we have x squared minus 2x plus minus 24 equals 0. So first step, we have to add 24 to both sides. So get the constant to the other side. So we get x squared minus 2x equals 24. So the next step, we have to go to the coefficient on the x term, and that's going to be our b value. So b over 2 squared is going to be negative 2 over 2 squared, which is negative 1 squared, which is positive 1. So we're going to add this to both sides of the equation. And what we're going to get is x squared minus 2x plus 1 equals 25. 24 plus 1 on the right-hand side, 25. So now this left-hand side can be factored. It would be two numbers that multiply to 1 that add to negative 2. That would be x minus 1 times x minus 1 equals 25. And that can be rewritten as x minus 1 squared equals 25. And now we're going to use the square root property here. So I would never actually, I'm never going to rewrite this intermediate step again, x minus 1 times x minus 1. We're just going to skip right to this step from now on. Okay, so now solving this, we have to square root both sides. So taking the square root on the left will cancel the square, and then that's going to equal plus or minus the square root of 25. So we have to remember that we get plus or minus when we take the square root of the right-hand side. And lastly, all we have to do here is, well, I'll keep the negative 1 on the left for now. We have x minus 1 equals plus or minus 5 because the square root of 25 is 5. and we're going to add 1 to both sides and get 1 plus or minus 5. So we have our two answers here. We're going to have x equals either 1 minus 5 or x equals 1 plus 5. So we just chopped up the plus or minus, so that means we're going to get x equals -4 or x equals 6. So these are going to be our solutions for our solution set. We get x equals -4 and x equals 6. Okay, so let's do a couple more examples here. X squared minus 6x plus 4 equals 0. So once again, let's get the constant on the right-hand side. So we're going to subtract 4 on both sides. And we get x squared minus 6x equals -4. And now we need to add b over 2 squared to both sides. Our b value is the x coefficient again, always will be. So that's -6 over 2 squared, which is -3 squared, which is +9. Okay, so we're going to add 9 to both sides of the equation. So on the left-hand side, we get x squared minus 6x plus 9. The right side, we get -4 plus 9, so we get 5. So on this left-hand side, this can be factored now. It's always going to be x plus or minus something squared. So two numbers that multiply to 9 that add to -6 are going to be +3 and +3. So it's x plus 3 times x plus 3, which is x plus 3 squared. So or x minus 3, sorry, x minus 3 because it was -6 they had to add up to. So it's x minus 3 squared. So the shortcut way for this is that value in here is always going to be your b over 2 value. So before you square it, it's your b over 2 value, which was -3 here. So finishing this off now, we have to take the square root of both sides. So we get x minus 3 equals plus or minus radical 5. And we're going to add 3 to both sides now. And we get x equals 3 plus or minus radical 5. And that is our two answers. X equals 3 minus radical 5 and x equals 3 plus radical 5. Okay, next one, x squared plus 4x minus 1 equals 0. Let's get the constant on the other side. We get x squared plus 4x equals +1. And now for the b over 2 squared, our b value is going to be 4 here. So that's 4 over 2 squared, which is 2 squared, which is 4. So we're going to add 4 to both sides. And we get x squared plus 4x plus 4 equals 5. And this is going to factor on the left, x plus or minus something squared equals 5. So two numbers that multiply to 4 that also add to 4, which is going to be 2. And once again, that value is right there. It's b over 2, which is our 2. So we can finish this off now. We can square root both sides. So we get x plus 2 equals plus or minus the square root of 5. Subtract 2 on both sides, we get -2 plus or minus the square root of 5, and that's actually as simplified as we can get because the square root of 5 cannot be simplified any further. And there is the answer as a solution set. Okay, let's do 2 more here. So we have 2x squared minus 3x plus 4. Let's add 3x to the left. So we get this. So we have the squared term and the x term on the left, constant term on the right. And notice that we do not have a coefficient of 1 here. So we actually have to divide both sides of the equation by 2, which essentially is going to be dividing every term by 2, because that will cancel off this 2 on the x squared term, giving it a coefficient of 1. So it'll become x squared plus 3 over 2 times x equals 4 over 2, which is 2. Okay, so now we can do our b over 2 squared method because the coefficient is 1 now. So unfortunately our b value here is a fraction. It's 3 over 2. So this is 3 over 2 divided by 2 squared, which is 3 over 4 squared. So this is just dividing fractions, keep, change, flip. That would be 3 over 2 times 1 over 2, which is 3 over 4. 3 squared is 9, and 4 squared is 16. So we're going to add 9 over 16 to both sides. So it's a little bit messier, obviously, because we're dealing with fractions. So on the left-hand side, we get x squared plus 3 over 2x plus 9 over 16 equals 2 plus 9 over 16. If we were getting common denominators for that, we would have to get 16, so we would rewrite 2 as 32 over 16, plus 9 over 16 is 41 over 16. Okay, so that's just getting common denominators, so I'll erase that. We don't need that here. Hopefully we're comfortable with that. And now for the hard part, or the seemingly hard part, we would have to factor that left-hand side. It's obviously a kind of a pain to factor with fractions, so let's use that shortcut method. And remember, it's always going to be this value, the b over 2 value right here. So it's x plus 3/4 squared equals 41 over 16. Okay, so now we can take the square root of both sides. That's x plus 3/4 equals plus or minus the square root of 41 over 16. And we subtract 3/4 on both sides. That's 3/4, negative 3/4, plus or minus radical of 41. So what I'm going to do here in one step, radical 41 is just radical 41. Radical 16 is 4. So we can give the numerator and denominator its own radical, and radical 16 ended up simplifying to 4. Okay, and just leave it like that. We can combine it in one fraction if we want. It doesn't really matter. So I'll leave it just like that. So we get negative 3/4 minus radical 41 over 4 and negative 3/4 plus radical 41 over 4. Okay, let's do one more here. We have x times x plus 7 equals 2. So what we have to do for this is we have to distribute the x first to get it in the proper form. So x squared plus 7x equals 2. So we're good to go to add b over 2 squared to both sides because we have the constant on the other side. So here's our b value, which is 7. So b over 2 squared is 7 over 2 squared, which is going to be 49 over 4. So we're going to add 49 over 4 to both sides. So once again, kind of messy here. So we get x squared plus 7x plus 49 over 4 equals 2 plus 49 over 4. We would have to get a common denominator. 2 would become 8 over 4. 8 plus 49 gives us 57 over 4. Okay, so now being able to factor that left-hand side, we get x plus or minus something squared equals 57 over 4. Once again, we're dealing with fractions, so it's kind of a pain, but we use the shortcut, and we say, okay, that number that goes in right there is b over 2. So it's x plus 7 over 2 squared equals 57 over 4. We take the square root of both sides. We get x plus 7 over 2 equals plus or minus the square root of 57 over 4. Subtract 7 over 2 on both sides. We get negative 7 over 2 plus or minus. I'm going to give the square root to the numerator and denominator. Square root of 57, I'm just going to leave it like that. And the square root of 4 is 2. And we will just leave that as our answer. So as a solution set, we get negative 7 over 2 minus radical 57 over 2 and negative 7 over 2 plus radical 57 over 2. So keep in mind there's just two answers here. but they're just kind of nasty fractions with radicals. But you could type them in the calculator if you really want to, if pretty much only if the question is asking for a decimal. But these are the two answers for this one. Okay, so that is it for completing the square.